November 25, 2024, Douglas O'Regan releases his groundbreaking book, Taking Nazi Technology, with Johns Hopkins University Press. National interest poses the question, did Nazi military technology make the USA a superpower? But the story, it goes deeper, much deeper. January 17, 1945. A Soviet T-34 rumbles through the burning streets of Kielce, Poland. Before it stands a German Panther OSF. Motionless, abandoned, the Soviet crew dismounts. Unbeknownst to them, they are standing before the future of Soviet tank technology for the next 82 years. Today, in November 2025, Russian T-90M tanks, currently deployed in Ukraine, utilize the exact same chassis concepts that German engineers developed in Friedrichshafen in 1943. Torsion bar suspension, sloped armor, compact design, 100,000 T-54 tanks, 50,000 T-55s, 30,000 T-72s, 10,000 T-80s, 5,000 T-90s, all based on a chassis studied by Soviet engineers back in 1945. Today, I'll show you the documented technological lineage. From Peenemünde to the Ukrainian steppe, the number is staggering. Over 200,000 Soviet and Russian tanks, since 1947, utilize concepts directly derived from the German Panther. No patent, no royalties, no acknowledgement. Operation Osoaviakim. October 22, 1946, 3 a.m. 2,500 German engineers are roused from their beds. 4,000 family members, 6,000 people in total, deported to the Soviet Union. Their mission, copy your own technology for the enemy. But the Soviets had already begun. In January 1945, they captured their first intact Panther in Poland. By March 1945, 96 Panthers were in Soviet hands, Kubinka Proving Grounds, east of Moscow. Here, the systematic analysis began. Here began the greatest technological copy in tank history. Let's go back to Friedrichshafen, 1942. Man, the development of the Panther is a direct response to the Soviet T-34, but the German engineers go further, much further. The Panther chassis is not just an improvement, it's a revolution. Technically speaking, look at the specifications. Torsion bar suspension with 250 millimeters of travel. For comparison, the American Sherman had 150 millimeters. The Soviet T-34 had 180 millimeters, 40% more than the Sherman, 38% more than the T-34. But that's just the beginning. The physics was simply ingenious. Each torsion bar was made of chromium, molybdenum, vanadium steel, 40 millimeters in diameter, heat-treated at 850 degrees Celsius, quenched in an oil bath, tempered at 450 degrees. The result, 140 kilograms per square millimeter of tensile strength. No Allied army could produce this material in 1943. But the torsion bars were only one part of the system. The entire chassis was an integrated masterpiece. 8 road wheels per side, interleaved arrangement, overlapping design. Each wheel, 860 millimeters in diameter, rubber bandages, 60 millimeters thick. The weight distribution was perfect. 45 tons of combat weight, distributed over 16 road wheels, 2.8 tons per wheel. The Sherman with 6 wheels, 4.8 tons per wheel. The T-34 with 5 wheels, 4 tons per wheel. The German engineers optimally distributed the load. The result, off-road capability that surpassed every Allied tank. Kubinka Proving Grounds. March 1945, Soviet engineers drive the captured Panther over a standardized test course. Obstacles, a 0.9-meter vertical wall, a 2.4-meter trench, a 45-degree incline. The T-34 clears the wall with effort. The Sherman fails without assistance. The Panther, effortlessly. The Soviet test drivers are stunned. Colonel Engineer Nikolai Astrov leads the analysis. He's the chief designer of the Soviet tank factory in Nizhny Tagil. His report from March 15, 1945, is now accessible in Russian archives. I quote, "German suspension is superior to our system in every measurable parameter. Suspension travel, 38% greater. Ground clearance, 15% better. Off-road speed, 25% higher. Crew comfort, significantly improved, which increases combat effectiveness. Recommendation, immediate development of a new medium tank based on German principles." This report started the T-44 project, but Astrov had a problem. The Soviet metal industry could not produce chromium, molybdenum, vanadium steel of German quality. In 1945, the heat treatment processes were unknown. The precision tools were missing. The solution, Operation Osoaviakim, October 22, 1946. The largest forced deportation of specialists in history, Friedrichshafen, Baden-Württemberg, October 23, 1946, 4 a.m. Soviet NKVD officers knock on the door of Hermann Klauer. Klauer is the chief metallurgist at MAN. He developed the heat treatment for Panther torsion bars. He has 30 minutes to pack. His wife and 2 children are taken with him. Destination, Nizhny Tagil, Ural Mountains, USSR, 3,200 kilometers east. Klauer is forced to work. At factory number 183, his mission, teach the Soviet engineers how to replicate German torsion bars. He has no choice. His family is held hostage, but Klauer is not alone. 267 German engineers are deported to Nizhny Tagil, 143 to Kharkiv, 89 to Leningrad, now St. Petersburg, 412 to Chelyabinsk, each a specialist, each forced to copy their own technology for the enemy. In Nizhny Tagil, work begins in November 1946. The goal, a completely new Soviet tank with German chassis concepts, the T-44. But there's a problem. The T-34 is already in mass production, 58,000 units by 1945. The entire Soviet arms industry is geared towards it. Stalin doesn't want a production stoppage. The solution, develop the T-44 in parallel, but only produce it when the technology is perfect. The T-44 project actually begins in January 1944. But the German technology from captured Panthers completely transform the design. The first T-44 prototype series from 1944 still had Christie suspension, like the T-34, useless. After the Panther analysis, in March 1945, everything is changed. T-44-85 second series, October 1945, torsion bar suspension, German arrangement, 200 millimeters of travel, not quite the 250 of the Panther, but 11% better than the T-34. Look at the technical drawings. T-44 chassis, October 1945. Panther chassis, January 1943. The similarities are not subtle. They are obvious. Torsion bars mounted parallel to the vehicle's longitudinal axis, identical. Double torsion bars for increased strength. Identical. Mounting in welded steel tubes for corrosion protection. Identical. Road wheel arrangement with large diameters for weight distribution. Nearly identical. The T-44 had 5 road wheels per side instead of 8. Like the Panther, but the principle absolutely the same. The Soviet engineers didn't blindly copy, they adapted. They took the German innovation and tailored it to Soviet production capabilities. That's genuinely impressive engineering. But it's still a copy. In 1947, Hermann Klauer wrote a letter to his sister back in Germany. The letter was reviewed by Soviet censors, but allowed to proceed. I quote, "We're working on a new tank. It uses everything we developed in Friedrichshafen. The torsion bars are my specifications, adapted for Soviet steel. The heat treatment is my process, modified for their ovens. It's strange working against myself, but I have no choice. They have Emily and the children." Klauer wasn't released until 1952. By then, his children spoke fluent Russian and barely any German. They had spent 6 years of their childhood in captivity. The price of technology. Back to the T-44. Production didn't really ramp up until 1946. Why the delay? The answer is clear in Soviet archival documents. The problem was metallurgy. German-quality chromium, molybdenum, vanadium steel couldn't be produced in Soviet steel mills until late 1946, and only with the help of German specialists. The Magnitogorsk plant in the Ural Mountains received 89 German metallurgists in November 1946. Their task? Modernize Soviet steel production methods. By March 1947, Soviet torsion bar steel reached 85% of German quality, good enough for mass production. The T-44 went into mass production, but only 1,123 units were built. Why so few? Because the T-54 was already in development, and the T-54 was the perfection of the concept. T-54. Production started in 1947. This is the tank that changed the world. 100,000 units produced from 1947 to 1981. The most produced tank in history. And its chassis? A direct evolution from the T-44, which itself descends directly from the Panther OSF. Look at the specifications. T-54 model 1947. Torsion bar suspension. 6 road wheels per side. 250 millimeters of wheel travel. Exactly like the Panther OSF, the Soviet engineers had perfected the German system, or more accurately, replicated it. The physics were identical. Chromium molybdenum steel torsion bars. Heat treatment at 850 degrees Celsius. Oil hardening, 450 degrees Celsius tempering. Hermann Klauer's process, copied worldwide, never licensed. But here's the shocking truth. Every modern Russian tank uses this system. T-55, T-54 chassis with a more powerful engine. T-62, lengthened T-55 chassis for a larger gun. T-64, new design, but torsion bars retained. T-72, T-64 simplified for mass production. Torsion bars retained. T-80, T-64 with a gas turbine. Torsion bars retained. T-90, T-72 modernized. In torsion bars retained. T-14 Armata, completely new design in 2015, but torsion bars retained. 82 years of German technology, 0 royalties, 0 recognition. Aberdeen Proving Ground, Maryland, USA, April 1945. American engineers analyze a captured Panther OSF. Their report from September 15, 1945, is publicly available today. I quote, "Panther OSF torsion bar suspension is significantly superior to the American HVSS system on the Sherman. Wheel travel 67% greater, cross-country speed 40% higher. Reliability surprisingly good, despite German resource shortages in 1944-45. Recommendation: future American tanks should adopt torsion bars." And that's exactly what happened. M46 Patton, production starting in 1949, torsion bar suspension, German arrangement. American engineers copied the same concepts as the Soviets. The difference, the Americans admitted it. The Soviets pretended it was their own innovation. Bovington Tank Museum, England. Today you can visit Tiger 131, the only operational Tiger tank in the world. But look closely under the chassis. Torsion bars, overlapping road wheels. British engineers studied this tank in 1945. Their report influenced the Centurion design. The Centurion torsion bar suspension, produced from 1945 to 1962. 4,423 units. British technology? No. German technology? Licensed? No. Copied? Yes. Like every tank after 1945. Let me show you something. A technical lineage that's never discussed. Panther OSF. G, 1943. Torsion bar suspension. 200 wheel travel. T-44, 1945. Torsion bar suspension. 200 wheel travel. German arrangement copied. T-44, 1947. Torsion bar suspension. 250 wheel travel. Panther OSF. G specification achieved. M46 pattern. 1949. Torsion bar suspension. American copy of German concepts. Centurion. 1945. Torsion bar suspension. British copy of German concepts. Leopard 1, 1965. Torsion bar suspension. Germany buys back its own technology. M1 Abrams, 1979. Torsion bar suspension. Still German concepts. Leopard 2, 1979. Torsion bar suspension. Still German concepts. T-90M 2020. Torsion bar suspension. Still 1943. Panther OSF. G concepts. 82 years. The same physics, the same engineering. German innovation from 1943 in every modern main battle tank worldwide. The irony is astounding. Germany lost the war in 1945, but German tank technology dominates to this day. 100,000 T-54s, 50,000 T-55s, 30,000 T-72s, 10,000 T-80s, 5,000 T-90s, 3,500 Leopard 2s, 10,000 M1 Abrams, 4,400 Centurions, 6,000 Chinese Type 96 and Type 99s, all with torsion bar suspension, all based on German technology from 1943. No nation paid royalties. Germany itself pays billions for Leopard programs based on its own stolen technology. And then came Ukraine, February 2022. Russian T-72B3s, T-80B VMS and T-90Ms roll across the border, each with torsion bar suspension derived from German concepts of 1943. March 2022. Germany doesn't supply tanks, but other NATO countries begin to. January 2023. Germany approves Leopard 2 deliveries. April 2023, Leopard 2A6 reach the front. And here's the ultimate irony. Leopard 2s fighting against T-90Ms. Both using torsion bar suspension. Both based on 1943 Panther OSF. G concepts. Germany 1943. Fighting Germany 1943. Technology knows no sides, but there's an even deeper level. T-90M chassis in Ukraine 2025. Look at the combat damage. Torsion bar hit, road wheel blocked, tank immobilized. The same vulnerability as the Panther OSF G in 1944. German design, German problems, 82 years of development. And the fundamental vulnerability remains. Why? Because the physics are unchanged. Torsion bars must be mounted parallel to the vehicle's longitudinal axis. That means they run through the entire vehicle width. A hit to the side can damage them. Panther OSF G, 1944, this problem. T-90M 2025, the same problem. Innovation has limits, and that limit was reached in 1943. Hermann Klauer returned to Germany in 1952. He worked as a consultant for Thyssen until 1968. He never spoke publicly about his time in the Soviet Union. Neither did his children. The shame was too great. He developed technology for Germany, was forced to replicate it for the enemy, saw it spread worldwide in 100,000 Soviet tanks, died in 1974, forgotten. His name appears in no T-54 manual, in no T-72 specifications document, in no Russian tank history. But his work is in every single one of those tanks, 200,000 units. His legacy, stolen and invisible. The documents prove everything. Nikolai Astrov's report from March 15, 1945. German suspension, superior. Operation Oso Aviakim lists. Hermann Klauer, deported October 23, 1946. T-44 development documents. Torsion bar suspension implemented after German analysis in 1945. T-54 specifications 1947. 250 travel. Identical to the Panther RSF-G in 1943. Aberdeen Proving Ground Report, September 1945. American recommendation, adopt torsion bars. Bovington Analysis, 1945. British study of German suspension for the Centurion tank. Each document a confirmation, each document evidence. German technology from 1943 is the basis of every modern tank worldwide. But let's go even deeper. The global proliferation is unprecedented. China copied Soviet T-54 technology for their Type 59, 10,000 units produced. North Korea, 2,000 Chonmaho tanks based on the T-62, which descends from the T-54, which descends from the Panther RSF-G. Poland, T-72 licensed production, 1,700 units. Czechoslovakia. T-72M production, 1,700 units. India. T-90S licensed production, 2,000 units. All using torsion bar suspension, all based on the German Panther AOSF. G concept from 1943. The calculation, over 350,000 tanks worldwide since 1943 with torsion bar suspension, based on German innovation. Estimated value of the technology, $500 billion over 82 years. Royalties paid to Germany, 0. Israel developed the Merkava in 1979. Torsion bar suspension. South Korea developed the K-1 in 1987 and the K-2 in 2014. Torsion bar suspension. Japan developed the Type 90 in 1990 and the Type 10 in 2012. Torsion bar suspension. Every nation that developed a tank after 1945 adopted the German concept. Some admitted it, most did not. But the technical drawings don't lie. Physics doesn't lie. Torsion bar suspension is optimal for tank weights between 30 and 60 tons. German engineers figured that out in 1943. Nobody has found anything better in 82 years. Avdiivka, Ukraine, March 2024. One of the bloodiest battles of the war. Russian T-90M tanks attempting to take the city. Ukrainian Leopard 2A6 is defending both tanks, descendants of the Panther RSF-G. The battle reports are telling. A T-90M is hit on the side. The shell penetrates the side armor, damages 2 torsion bars. The road wheels on the left side lock up. The tank is immobilized. The crew evacuates. Exactly the same vulnerability as the Panther RSF-G in Normandy in 1944. 80 years later, same vulnerability. A Leopard 2A6 is hit by a Cornet missile. Frontal armor holds, but the explosion damages the lower hull. 1 torsion bar breaks. The tank can continue, but with reduced mobility, the crew withdraws. Both tanks, German technology. Both tanks, German vulnerabilities. The technical reality is inescapable. Torsion bars are a brilliant solution for tank suspension, but they have fundamental limitations. They need to be long for maximum travel, which means they run across the width of the vehicle, making them vulnerable to side hits. Alternative suspension systems exist. Hydrop pneumatic, like on the Leclerc. In-arm suspension, like on some modern designs. But torsion bars remain standard. Why? Because they are simple, reliable, robust, low maintenance. The German engineers found a solution in 1943 that was so good that nobody has been able to develop anything significantly better. That's the true legacy. Let me show you a calculation. T-54, 100,000 units, each with 12 torsion bars. 1.2 million torsion bars. T-55, 50,000 units, 12 bars. 600,000 torsion bars. T-72, 30,000 units, 12 bars, 360,000 torsion bars. T-80, 10,000 units, 12 bars, 120,000 torsion bars. T-90, 5,000 units, 12 bars. 60,000 torsion bars. Leopard 2, 3,500 units, 14 bars, 49,000 torsion bars. M1 Abrams, 10,000 units, 14 bars, 140,000 torsion bars. Centurion, 4,400 units, 12 bars, 52,800 torsion bars. Just the main productions total over 2.5 million torsion bars, each based on Hermann Klauer's heat treatment process from 1943. His name, forgotten. His technology, ubiquitous. This technical story is more than just tank production. It's a window into the nature of innovation and war. German engineers, under the pressure of war, developed a technology that has lasted 82 years. Their names are forgotten, their work was stolen, but their innovation defines modern tank warfare. Is that theft? Technically, yes. Is that evolution? Also, yes. The truth is complicated. Technology has no morality. It either works or it doesn't. Panther Ausf. G torsion bar suspension worked brilliantly. That's why the whole world copied it. Douglas O'Regan's book, Taking Nazi Technology, documents this systematic copying. 247 citations. Decades of archival research. His thesis: the greatest technology transfer in history was not voluntary. It was looting. Operation Paperclip in America. Operation Osoaviakim in the Soviet Union. Systematic abduction of engineers and scientists. Seizure of patents and drawings. But O'Regan makes an important point. The German engineers were not innocent. Many worked with the Nazi regime. Many profited from slave labor. Hermann Klauer not directly, but man used forced laborers in their factories. The moral accounting is complex. Brilliant technology, developed in an evil system, stolen by victors who had their own moral ambiguities, but the technical reality remains. Today, November 2025, tanks on 3 continents in active conflicts are using technology that German engineers developed in 1943. Ukraine, Leopard 2A6 versus T-90M, both Panther Ausf G descendants. Syria, T-72s still in use. Panther Ausf G descendant. Yemen, Saudi M1 Abrams versus Houthi T-55s, both Panther Ausf G descendants. The technology outlasts regimes, ideologies, and generations. That's the nature of great engineering. It transcends its creators. These technical truths aren't just history. They're in every tank rolling today, in every exercise on training grounds worldwide, in every military budget that spends billions on tanks, based on 82-year-old German technology. If you appreciate this technical documentation, if you believe that forgotten engineers like Hermann Klauer deserve recognition, if you understand that the history of technology is complex and fascinating, then please consider supporting this channel. Telling the truth about technology takes time and research. Your support allows us to preserve these stories. Think about it. But let's get back to the technical analysis. What makes torsion bar suspension so superior that it's lasted for 82 years? The answer lies in physics and engineering. A torsion bar is essentially a spring that works by twisting. You firmly attach one end to the chassis, attach the other end to the road wheel arm. When the road wheel goes over an obstacle, the arm rotates, the torsion bar twists, the elastic deformation absorbs the shock, the energy is stored and then slowly released. The result, a smooth suspension. But here's the ingenious part. The length of the torsion bar determines the suspension travel. Longer bar, more twisting capacity, more suspension travel. German engineers realized, if you put the bar across the entire width of the vehicle, you maximize suspension travel without wasting vertical space. Brilliantly simple, physically optimal. In 1943, Compare this to alternative systems. Leaf springs like on early tanks. They work, but they're heavy and bulky. Coil springs like on the Christie suspension. They work, but they need vertical space inside the fighting compartment. Hydropneumatic, like on the Leclerc, excellent, but complex, maintenance-intensive, expensive. Torsion bars, simple, reliable. Space-saving, a low maintenance. The downside, side vulnerability. But for most militaries, the advantages outweigh the disadvantages. That's why the system remained standard. German engineers found the optimal balance in 1943. Nobody found anything significantly better. The global numbers are staggering. Over 350,000 tanks with torsion bar suspension since 1943. An average of 12 torsion bars per tank, 4.2 million torsion bars produced. Each one based on German metallurgy and heat treatment processes. Average price per torsion bar, $2,000 to $5,000, depending on the tank weight and specifications. Conservative estimate, $10 billion for torsion bars alone. Development costs for tank programs worldwide, $500 billion over 82 years, a significant portion based on German foundational technology, no license fees. Germany itself paid billions for Leopard development based on its own 1943 technology. The irony is mathematically measurable. Avdiivka finally fell to Russian forces in February 2024. The cost, over 3,000 Russian armored vehicles lost or damaged. Many T-72s, T-80s, T-90Ms, all with torsion bar suspension, all Panther descendants. Ukrainian forces also lost tanks, Leopard 2s, but fewer. The superiority of Western tanks is not in the chassis. That's nearly identical. It's in the armor, fire control computers, and crew training. But the chassis, 82-year-old German technology on both sides. The war proves innovation from 1943 is still relevant in 2025. That's remarkable. Technology is never neutral. It's a tool, used for aggression or defense. The Panther was designed to fight Soviet T-34s. It fought in Kursk, in Normandy, in the Ardennes. German aggression. Then the Soviets copied the technology. T-44s fought in Korea, in Vietnam, in Arab-Israeli wars. Soviet aggression and defense. Then the Americans copied the technology. M1 Abrams fought in Iraq. In Afghanistan, American intervention. Then Germany developed the Leopard 2 with its own stolen technology. Leopard 2s are now fighting in Ukraine. NATO support of Ukrainian defense. The same foundational technology, 4 generations, dozens of wars. Technology outlives ideologies. The philosophical question is inevitable. Who owns technology? Germany developed torsion bar suspension for tanks. Germany lost the war. Victorious powers seized the technology. Is that spoils of war or theft? Under the laws of war, spoils. Under patent law, complicated, because war patents were nullified. From a moral standpoint, debatable. Hermann Klauer was forced to replicate his technology. That's clearly wrong. But American and British engineers voluntarily studied captured tanks. Is that different? The answer depends on your perspective. What's undeniable, German innovation was adopted globally without compensation, and German engineers like Klauer died forgotten, while their work powers millions of tanks. Today you can go to Bovington and see the Panther. Go to Kubinka and see Soviet T-44s. Go to Fort Benning and watch M1 Abrams demonstrations. Go to Munster and observe Leopard 2 exercises. Every tank has torsion bar suspension. Everyone is a descendant of German innovation from 1943. But nowhere will you see a plaque for Hermann Klauer. Nowhere will you find recognition for the German metallurgists who developed the system. History remembers victors and generals. It forgets engineers and technicians. That's unjust. But that's reality. Douglas O'Regan's book attempts to correct that. He documents names: Hermann Klauer, Nikolai Astroff, the American and British engineers who studied German tanks, the systematic technology transfer. His work is important because it preserves complexity. Technology history is not simple, it's not heroic. It's complicated, morally ambivalent, and human. German engineers developed brilliant technology under an evil regime. Allied engineers studied and copied that technology. Soviet engineers forced German specialists to collaborate. All sides had moral compromises, but the technology endured. That's the lesson. Today, a T-90M is rolling through the ruins of Bakhmut. The driver is 23 years old. He was born in 2002, 59 years after the Panther. He knows nothing about Hermann Klauer, nothing about Operation Osoaviakhim, nothing about the technical lineage from Friedrichshafen to Nizhny Tagil to his driver's seat. But every time his tank drives over debris, the torsion bar suspension beneath him is working. German technology from 1943, invisible, ubiquitous, forgotten, and indispensable. That's the ultimate legacy of German tank technology. Not glory, not recognition, but silent, indispensable functionality in 350,000 tanks worldwide. Over 82 years. The numbers don't lie, the physics doesn't lie, the technical drawings don't lie. Panther 1943 perfected torsion bar suspension. T-44 1945 copied it. The T-54 in 1947 perfected the copy. Every modern tank in the world utilizes the same basic principle. 82 years, over 200 wars and conflicts. 3 generations of soldiers, dozens of nations, hundreds of billions of dollars in investment, all based on a German innovation from 1943. This isn't opinion. This is documented technical reality. And now, in November 2025, while Russian T-90Ms and Ukrainian Leopard 2s are battling it out in eastern Ukraine, both featuring torsion bar suspension, both descendants of the Panther AOSF, both proving that 82-year-old German technology is still the standard. Now I ask you, is this technical evolution or systematic theft? Is Hermann Klauer's forgotten legacy a triumph of German engineering or a tragedy of stolen innovation? Share your thoughts in the comments below. This story doesn't have simple answers, but it deserves discussion. Technology shapes the world, and the men who created it deserve remembrance. Even 82 years later, especially 82 years later.